All right, this is 1.6 part 1, and it'll get broken into 2 full days. So we're going to do the first part. Today we're just going to talk about these bottom 3 things. And that's it. Tomorrow we'll do the rest of this, hopefully. I don't know, we'll see. All right, so 1.6 is about solving systems of linear equations. And here we have a graph, and it says what are the approximate coordinates of the point of the intersection? Because that would be where the solutions are, and it's about right there. I don't know, it's a little over 3, let's say, and I'm going to miss this on purpose, let's say 3.1 and 4.7. It's close, but not perfect, okay? And that is the problem with graphing. Now, how could you verify whether the coordinates you estimate are in fact the solution? Is the point of the solution the equations of both lines? I guess you could do things like plug numbers in, but you're going to have equations, and that's what they want you to do. They want you to write some equations, and I've already done that for you. Here is a system of equations, and the system of equations for this one is 3x minus y equals 5 and x minus 2y equals negative 6. And there's a couple of different ways you can solve systems of equations. You've got substitution, maybe you remember that, where you solve an equation for one variable and then plug back in. There's the transitive property, which a lot of middle school teachers like. Transitive property is what I'll do on this one. It says if two things are equal to the same thing, they equal each other. I hate it when it does that. Let's just start typing. If two things equal the same thing, they are equal to each other. And I'm going to do this one with the transitive property. I've noticed that a lot of my kids cannot convert to y equals mx plus b. You know, slope-intercept form. Y equals mx plus b. Well, the nice thing about putting both these in y equals mx plus b is they'll both equal y. And I'm going to do this. I'm going to put the y over here and the 5 over there. 3x minus 5 equals y. This one a little more work. I'll probably do it more proper. Negative 2y equal to negative x minus 6. Divide out the negative 2, and that would give me that y is 1/2 x plus 3. Now you'll notice that this piece and this piece both equal y, and that's the definition of the transitive property. If two things equal each other, then they are equal to each other. So we're going to set 3x minus 5 equal to 1/2 of x plus 3. And I don't like that there's a fraction, so I'm going to double everything. 2 times 3x being 6x, take away 10. Half times 2 is just 1. 2 times 3 being 6. And let's shift our x's left and our numbers right. 6 minus 1 is 5, so 5x equal to 10 plus 6, 16. Now, way too many of my juniors this year are making small mistakes in adding and subtracting. That's something you need to be fixing. Anyways, we divide by 5, and 16 over 5 is exactly 3.2, pretty close to what I said it might be. Now, if I want y, I can just plug it back in. So 3 times 3.2, take away a 5 is my y value. 3 times 3.2 is 9.6. 9.6 take away 5 is 4.6. So I was pretty close. So it turns out the exact ordered pair is 3.2 and 4.6. Now remember, graphs in algebra, one is not superior to the other. They reinforce each other. They complement each other very, very well. Very well. If you want to be great at math, understand graphs. If you want to pass Milbrath-Math class, at least start to comprehend them, okay? All right, how can you find and represent solutions of systems of linear equations and inequalities? Well, you could graph. You could do what we did, which was the transitive property, or you could do substitution or elimination. I'm going to make this particular slide about substitution. Okay, so let's go over the substitution method. Substitution. This one, the one that's on paper right now, is actually best done with elimination. But substitution method, you solve one equation for either x or y, whichever one's easier, and substitute into the other equation. So I'm going to solve the top equation for x because it looks really easy to do. It's just a simple shift right. And it tells me that x is 3y plus 12. Now that I know what x is, I'm going to take that quantity and I'm going to put it right there. So 3y, that's called substitution, plus 12, plus what I already have, 2y, must be 7. 3y and 2y is 5y. 5y plus 12 is 7. Subtract 12 and I get negative 5. Divide out the 5 and I get negative 1. And now that y is known...
Teacher, pardon the interruption. Sean Colbert, come to the office, please.
I can plug it right in to there. So x is going to be 3. A y is encountered. Its value is negative 1 plus 12. That's going to be negative 3 plus 12, which is 9. So the ordered pair 9 and negative 1 exists. Now, I don't expect you to remember this, but this is talked about in Algebra 1. This thing has a solution that makes it consistent, okay? Has a solution. That's what we call consistent. And it has, specifically, it has a unique solution that makes it independent. So we would classify this as consistent independent because there is such a thing as dependent. So you actually have to clarify which one is it. Consistent means there's an answer. Independent means there's one. All right, and here's your slide going over classification. This one's a lot like the last one. Two lines that intersect is classified as consistent independent. Lines that do not intersect, they have parallel slope, and a different y-intercept are classified as inconsistent. That's it. We don't see anything else because they don't have an answer. They're just called inconsistent. Now you couldn't tell by looking at your notes here, but there's actually two lines here covering each other all the way up. We have an infinite number of intersections. We have the same y-intercept, same slope. Because we have solutions, we are classified as consistent. But because there's an infinite number, the lines or the solutions are said to be dependent upon each other. There we go. Consistent. I'm missing something. Consistent. Dependent. That just looks wrong. Consistent. Yeah, I need another S there. I had a moment apparently. Consistent, dependent. Anyways, there's your classification. All right. Now, how are we going to solve these? I am going to, so far I have done transitive property and substitution, which are supposed to be refreshers, but I want to talk about the elimination method from here on out. Elimination method. The elimination method adds or subtracts multiples, if needed, of one equation from another so that a variable is eliminated. And you know, the biggest deal we have with the elimination method is kids' ability to do arithmetic and multiplication and division. Like, it's just the big deal. It's just, there's so much fifth grade math. Like, oh my Lanta. Fifth grade math is where it's at. Anyways, I'm going to do the elimination method. And I think I'm going to multiply the top equation by 6. And hopefully you'll see why. That'll give me 12x plus 6y equals negative 6. I'm going to leave the bottom one alone. I am going to, not 6. Let me erase that. The author of this question was hoping that this would be a big enough distractor, and apparently for me it was this morning. I don't know why I did 6. I'm going to multiply the top by 3. 3 times 2x is 6x. 3 times y is plus 3y, and that would equal negative 3. And we're going to leave the bottom equation alone. We're just going to put it in standard form. And if I add down, you'll see that the x's disappear because 6 plus a negative 6 is nothing. And then I'll have 8y, and negative 3 plus 7 is 4. Divide out my 8, and I'll have a y value of a half. Now I get to go back and use a substitution property. Okay? I'm going to plug that into an existing equation, and the easiest one to plug into is probably this one right here. So 2x plus y, which has a value of a half, must be negative 1. I'm going to subtract a half from 1, and I shouldn't have to do this, but kids don't believe me when I do math in my head. Negative 1 minus a half back as a fraction is negative 3/2. And then I'm going to divide by 2. Now, division happens in the denominator, so I'm going to get negative 3/4 when everything is said and done. And I know, again, you don't believe that little trick, but I took a negative 3/2 and I divided it by 2, and by golly, it's negative 3/4. Number sense is where it's at. So the solution, and it is unique because there's only one, was at negative 3/4, negative 1/2, positive 1/2. Now, classifying it, we have solutions. That makes it consistent. And we had a unique one that makes it independent. It is consistent, independent. Now, moving on to the next example here. On this one, I am going to multiply the top by negative 2, and there's lots of ways of doing it. But remember, I want to eliminate a variable, and I saw 3 and I saw 6 on the x's. If I multiply by negative 2, I'll have negative 6x minus 4y. Remember to use the distributive property here. Everything gets that negative 2 attached to multiplication. And this one's kind of unique in what happens. We'll have no x's, we'll have no y's, and we'll be equal to 7 on the right-hand side. If I take no x and no y and add them together, I have a 0. And I get this funny looking thing. It says 0 is 7, which is by definition false. Now pause the video, take a few seconds, look it over how you think that might be classified. It has no solutions, okay? You know, when I say that, I'm saying look back. No solutions, right there. That is inconsistent. Now, if I want to support my math, and if I had 5 minutes of time here, I'd freehand graph these things. But let's just take a look on good old Desmos and see what she says. We got 3x plus 2y equals 5. Desmos is great, by the way. Way easier to use than TI-84. But can't let you use your laptop on a test. 6x, because if I did that, I'd have to walk around the room and I wouldn't have time to grade. There are parallel lines which do not have intersections. That's why it had no solutions. Now, I know some of y'all have not realized that parallel lines never intersect. I don't know how you pass 6th grade math, but whatever, you're here. Start accepting it. Moving forward. Solve an application of linear inequalities. Malcolm earns $20 per hour mowing lawns and $10 per hour walking dogs. Let's see here. Let's make one of these axes dogs and one of them lawns. I don't guess it really matters what we do here. So let's do this hours mowing. Yeah. Hours spent mowing. We'll call that an M. And we'll make the vertical axis hours spent walking dogs. And we'll make that a W. Oop, wrong one. There's other ways of doing this one. Alright, now he gets $20 per hour mowing yards and $10 per hour walking dogs. So 20 times M plus 10 times W, he wants to earn at least $200. So that would be a greater than or equal to system. love that this has this glitch. 200, there's one equation. Let's see, because he wants to earn at least $200 a week. He can work a maximum of 20 hours. So the number of hours he spends mowing plus the number of hours he spends walking dogs has to be less than or equal to 20. This is called a system of inequalities. It's got another notation. Oh, what is this usually called? I had it on my mind earlier and I done forgot. It'll come back to me. It's got a shorthand name. Anyways, I'll probably remember by the time I give a lecture in class. Let's see, he has to spend at least 5 hours per week walking his neighbor's dog. So walking has to be greater than or equal to 5. And what else? Of course, we know that if you put the two things together, they have to be greater than or equal to 0. But that's already given on that one. I feel like this is the two equations I need. So let's take this one and kind of make it look like y equals mx plus b. By the way, remember this is the x-axis here. And I guess instead of using m's, I should use x's. Let's do that. That'll make this problem make more sense to kids. That's x, that's y. I was trying to use descriptive variables, but sometimes descriptive variables, they just don't make sense. Alright, this is enough information to graph. Now, to graph things, we'd like to be in y equals mx plus b form, right? So, 20y equals, oh, no. That should be an x. Mowing is x. Dogs is y. $10y equal negative 20x plus 200. I'm going to drop the inequality symbol for just a minute. Divide out the 10, and y is equal to negative 2x plus 20. Alright. Let's start this. Let's count here. We got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We'll just count by twos. We cross the y-axis at 20. We need to go out to, he can work a maximum of 20 hours. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So he's going to fall 2 and run 1. But yeah, we have a -2 slope. Fall 2, run 1. 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 Now, the original inequality symbol was greater than or equal to. So this is saying shade that way. I'll get the colors out in a second. X plus y is less than or equal to 20. If we solve that for y, that's y is less than or equal to negative x plus 20. Starts in the same spot, but it only falls 1 and runs 1. And it's a less than or equal to, so it's going to be telling you to shade below. So it's going to want you to shade below. You should remember doing colored pencils on this one. We have a line that says y is greater than or equal to 5. So remember 2, 4, 6, about halfway through here. This would be 5. It's a horizontal line. And it is saying shade above. Anywhere in the shaded space is a solution. Okay. Another idea is this is the maxes and the mins happen at the vertexes. Okay. And let's say we want to maximize his income, okay? So remember that this was 5. 2, 4, 6, 8, 10, 12, 14, 16. This is probably 15, 5. 15 on X, 5 on Y. Of course, we're freehanding here. That always makes it fun. 2, 4, 6, 8. Oh, what's this? I don't know. I know that this one is going to be 0, 20. You know, what's that other one? I don't know. I guess I'd have to do a little algebra to figure out where those three things intersect. But anything in there, I'm good. And this thing has an infinite number of answers. I wish I knew the intersection of that one. That is the intersection of y equals 5 and the purple line. So let's see where they intersect. 5 equals negative x plus 10. Nope. Purple line is the first one. It's this guy right here. Negative 2x plus 20. Yeah, it's an oddball, and it's going to be 7.5. 15 equals negative 2x. X equals negative 7.5. Alright, so this ordered pair is at positive 7.5. I must have made a side mistake somewhere. Negative 15. There we go. Positive 7.5, comma 5. Now let's just plug in and see where our profit is maximized here. This is probably it, because 15 times 20 is 300, plus he gets 10 here, 50. This is $350. That's probably where you maximize income. He's not even working 20 hours here. 7.5 times 20 is 150 plus 50. This is $200. And up here, he only gets 10 for walking dogs. This is also $200. Now, if he just wants 200 bucks, and that's all he wants is $200, this one. But if he's a little bit of greed in him, this is the max. This is for if he's lazy, okay? I guess up here is if he likes dogs, because that's all he's doing is walking dogs. But each vertex represents something in the real world. Oh, and I still cannot think of what you call doing this. That's just really bad. Like, I'm a math teacher and I forgot this, and I've said this word 1,000 times over the last 15 years. I must be getting old. It'll come to me in about 10 minutes as soon as I quit recording. Alright, this is a try it, but it's a video, so I may as well do it. Sketch the graph of the set of all points that solve the system of linear inequalities. So we're going to do y equals mx plus b first. We're going to have negative 2x plus 14. We're going to do the same thing here. Shift the x over. 2y less than or equal to negative x plus 10. Y is less than or equal to negative 1/2 x plus 5. And these, I wish every student alive could graph them, but they can't. X equals is vertical. Y equals is horizontal. I get that you feel it is not important. I am supposed to be bigger than 0. Y is supposed to be greater than 0. I'm supposed to shade up. X is supposed to be greater than 0. It's saying shade right. Could have swore I changed colors. And I need to graph these. I need to go to 14, don't I? That won't be too bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is about right there. And I've got to fall 2 and run 1. See, that would put me around what? 12 and then 10. Should put me about right there. Fall 2, run 1. I can check that. I can find an x-intercept by letting y equal 0. And x is 7. I did that for y'all, not me. So yeah, that's pretty good. And what is the inequality telling me to do? Saying less than. Shade left. So there's a big triangle right now that's wanting to be shaded out. Now we got one more equation to do. It's this one. Negative 1/2 x plus 5. That means we fall 1 and we run 2. This one is wanting you to shade. That's a less than sign below. So our solution space is all of this territory right here. Alright, let's go ahead and figure out where the maxes and the mins are. Of course, plotting pairs is always a challenge. Now, it would be really nice if we had a profit function here, wouldn't we? But in this particular example, that doesn't make any sense. But that shaded area is where all these solutions are. Oh, it's killing me. What do you call this? I cannot believe I forgot this. I remember glancing at this lesson and thinking of what you actually call this stuff. And it's gone. It's got a cool name too. Well, I forgot. It's probably about time for me to retire now. The old memory is starting to fail me. Anyways, there is the first part of 1.6. Hopefully by class I'll have that remembered.